Okay, so everybody's here. Let's do a full revision of everything. We'll start with runway incursion. 30 minutes, I want to go through a quick revision. Maybe add a few more extra information to topics you've already covered. I'm going to ask a lot of questions to you guys. So throughout the pilot training, ATPLO, CPLO, no matter which theory classes you're doing, be ready for a lot of question answers. Especially when I was based in the Airways Aviation Academy in Europe. On day one, we would start asking questions. If an aircraft is flying or a car is driving at 80 miles per hour, 7 minutes, how many miles, how many kilometers would you cover? These type of questions. I'm going to expect you guys to do this tomorrow. So tomorrow, whoever is in the class, doesn't matter, aircraft or, so you guys already know what is the formula for distance, time and speed, right? Let's start with that. What's the formula for distance, time and speed?
Speed equals to distance.
Let's start with distance first.
Distance equals to speed into time.
Distance is equal to speed into time. You sure about that?
Speed
Can you
upon
bet your life on it? Distance is equal to speed multiplied by time. Is that what you said?
Yes,
Are
sir.
you sure about that?
Yes, sir.
Are you sure? You don't seem sure. D is equal to? Now, pen and paper method is what I want you to practice. But when you're flying an aircraft, you're not going to have time to pull out the pen and paper or the calculator. You have to get to a point where you mentally calculate. Aviation math and physics is super important. So as the first few days of the foundation course, I want you all to get to a point where by the time you reach navigation, you're already mentally prepared for mental math. What type of temperatures do we expect above a certain height? Now, we know from the previous class that there is a 2-degree temperature drop every time we go higher, right? You guys know that because I saw on the whiteboard,
Yes.
Anaga had covered up some of those topics. Now, the practical implication would be, you're flying at 20,000 feet, and immediately, now 1.98 degrees is according to the ISA, International Standard Atmosphere. But guess what? 1.98 is a very difficult number to mentally calculate. So we round it off to 2 degrees just for it to be easier. So what I expect you all to do is, tomorrow I'm going to ask you questions like, the aircraft is flying at 20,000 feet and the temperature is already minus 5 degrees Celsius. What's the temperature at 40,000 feet? Boom, I need the answer in less than 10 seconds. So you're like, okay, 20,000 feet up in the air, the temperature is already what? Minus 5. So I'm going from 20 to 40,000. So 20,000 more higher. If I go higher, the temperature drops by 2 degrees. Agreed? So in 20,000, the temperature will drop 40 degrees, 20 multiplied by 2. So it will be 40 degrees colder than what it was at 20,000 feet. So minus 5, another 40 degrees in negative, minus 45. This should take you less than 5 to 10 seconds, right? Be very careful. Sometimes the question will be, the aircraft is flying at 20,000 feet and the temperature is 0. It could be, right? What's the temperature on the ground? So you now have to go 20,000, 19, 18, 17, all the way back. So you're going 1,000 feet lower, 2 degrees increase. By the time you reach the ground, it's 20 multiplied by 40 degrees hotter. So it's already 0, it will be now 40 degrees positive. Be very careful about that. Or sometimes they'll ask you, the temperature on the ground, let's see, according to my watch, Hyderabad, the temperature right now is 34 degrees Celsius, right? So let's start with you, sir. The temperature on the ground is 34 degrees Celsius right now. What's the temperature right now at 10,000 feet? Everybody can write it down and try to calculate it. 34 degrees on the ground.
24 degrees.
Are you sure? His answer is 24. I don't think so it's the right answer.
14.
Sorry?
14.
So I want you all to try to use a pen and paper method and try to calculate it.
It's 14.
It's 40.
Write it down, everybody. Are you sure? So on the ground level is 34. The temperature at what altitude did I say? 20,000. Sorry?
10,000.
Yeah,
I said 10,000, right?
10,000.
So 10 multiplied by 2 degrees is 20. So it will be 20 degrees colder. 34 minus 20 will be
14.
14.
14.
So it's not that difficult, right? This is the type of math you need to expect. Your grocery guy can do this much faster than you can because he's used to crunching numbers every day in his grocery shop. Homework, go work in a grocery shop today, right? So basically get better in basic multiplication, division, addition, subtraction. You don't really need trigonometry calculus at this stage. Maybe some trigonometry and navigation later on, but not much. The other type of math I'm going to expect all of you by tomorrow is to be able to calculate percentages mentally very quickly. What is 18% of 2,500? At least come up with an approximate number mentally without a pen and paper. You're going to be flying during instrument stage and you'll be required to do certain calculations where it will be a percentage of a certain number. To do an instrument turn, there's a percentage of a certain number which you need to calculate and do the turn accordingly. Engine, speed, sometimes there'll be like increase speed by 10%, increase RPM by 10%. You can't like, now, come up with a way which works better for you. If you are unable to find out a certain percentage of a certain number mentally, break it down, maybe round it off. It's always easier to find 10% of any number, get rid of one digit in the end, right? So if I say 10% of 1,800, you know 10% of 1,800 is just get rid of the last digit, 180, right? So break it down and then maybe double that number to come up to the number which you want to actually calculate. So most of the times they say in aviation math, you don't actually calculate, you do a well calculated guess. Make sense? You're going to be flying and all of a sudden the instructor will pull the engine and he'll say you just lost your engine, where can you land? Tell me an approximate distance to your nearest landing spot. So you'll point at a place saying probably that would be the right place, but how far away is that place? And at this moment your engine's shutting down, right? It's nice and quiet, which is never a good thing. And you have to calculate quickly how far away is that airport. So you are literally flying with one hand, using your right hand, pulling out the chart, using a scale, 2 inches, 3 inches. So on a navigation chart, each inch is almost 10 nautical miles. I mean, depends on which sectional chart you're using. 1 is to 250 or 1 is to 500. So you need to know what chart you're using and you need to approximately calculate how far away is that on the paper. You need to know where you are to begin with. There's a lot of things happening, but the most basic thing which you can study about today to get there is be able to crunch numbers fast. Basic multiplication division. So ask a lot of questions to each other. There's 8 of you, right? There's 8 of you in the class. You should all be coming up in every other break, and lunch breaks shouldn't just be lunch breaks where you're just sitting and doing nothing and eating. Sure, eat, but even while you're eating or having a little discussion, throw a question at them saying, all right, aircraft flying at 4,000 feet, temperature 25 degrees negative. What's the temperature on the ground? And you might, okay, keep crunching, have a bite or two, I think the temperature is so and so. Make sure you do a lot of these activities, because as I was telling you yesterday, when you jump into the oral exam, that's when you realize how difficult it can be. The oral exam is what you have to always be prepared for. And most importantly, you don't just pass the exam and say, all right, I have a percentage on my score sheet. It's about real flying. When you're flying, if you don't know something, that's exactly what's going to put you in trouble. So please, this is not like high school where you just memorize certain things and pass. I know, unfortunately, a lot of schools around the world have created that habit where you just wing it, you just memorize it and keep moving forward. Eventually, you're going to get in trouble if you do that in the world of aviation. So keep the math and physics. So the next topic, which I'll also ask you guys tomorrow, again, percentage and distance, time and speed related questions. Now that we're done with temperature, I'll also introduce you guys to pressure. Okay? Did we speak about pressure? Did Anada cover pressure already?
Yeah, sure.
So the pressure is approximately how much?
1.19.
1 point, no, nothing to do with 1 point.
1013 point.
1013.2? What is it? Kgs? Hectopascals. You gotta be very specific. So the pressure 1013.2 is an ideal, it's according to the ISA, International Standard Atmosphere. I can bet that it's never gonna be 1013.2 when you check in your house. If you have a barometer, an instrument to measure pressure, it'll probably never be 1013.2. Ideally speaking, it is 1013.2. Now, let's say it is 1013.2 if the temperature outside is 15 degrees Celsius, if the density of the air is 1, 122,
1.225.
No.
1.225.
1225 what? Kilometers, miles?
Kilograms per meters.
No, it's not miles. Density, I think. How can density be in miles? I mean,
Grams.
1225 grams per meter cube. So pressure is imagining a box. You've got a box. The box is 1 meter this way, 1 meter this way, and 1 meter this way. A cube. Length, breadth, height. Take a glass box, cardboard, whatever. Remove the weight of the box. Made of glass, made of cardboard, paper, whatever, doesn't matter. I've taken a box, 1 meter, 1 meter, 1 meter, length, breadth, height. The amount of air inside that box has a weight. Even air has weight, obviously, very little. If you take an aquarium, right, full of water with fishes, 1 meter, 1 meter, 1 meter length, breadth, height, and there's a lot of water in it. It will be super heavy, you cannot carry it, it'll be that heavy. I don't know how many, but it's going to be super heavy, right? But, same aquarium full of water, full of air, same 1 meter, 1 meter, 1 meter, has air, and that has a certain amount of weight. And that weight happens to be only 1.2 kgs, 1.225 kg, which is 1,200. So approximately 1,200 gram is the weight of the air inside a box, which is 1 meter, 1 meter, 1 meter, without calculating the walls, without calculating the weight of the wall. Does that make sense?
Yes.
That's what density is. The amount of air molecules, if they're very close to each other, there's way too many air molecules inside that box. Now the density might be 1.5 kgs per meter cube. Either it's 1 point so and so kgs per meter cube, or it is 1225 grams per meter cube. Grams or kgs, same thing, right? I can say I am 85 kgs, or I can say I am 85 multiplied by 100 grams. Something like that. Make sense? Everybody? Multiply 100 or multiply by 1,000?
1,000.
Guys, I may say something incorrectly by mistake, or I might say something incorrectly to test if you're listening to me. Might be the first one which happens more often than the second one, but please stop and correct if you think if I said something wrong. Is everybody okay with that? So tomorrow, as soon as I come after lunch break, I'm going to ask you all mental math, temperature, pressure, and distance times speed. So about the pressure on the ground in ideal scenario is 1013.2 hectopascals. 1013.2 hectopascals, round around. Every 30 feet I go higher, right? Every 30 feet I go higher, it'll drop by 1 hectopascal. Everybody okay with that? So temperature lapse rate is every 1,000 feet minus 2 degrees. Agreed? Pressure lapse rate is every 30 feet 1 hectopascal reduction. So the more higher I go, the air pressure keeps dropping and dropping and dropping. So I'll ask you some questions tomorrow. The pressure on the ground, let's assume, is 1013.2 hectopascal as per the ISA. I am standing at 90 feet above the ground level. What's the new pressure? So 30, 30, 30. 3 minus 3. 1013.2 minus 3. That is 1010.2 hectopascals. Make sense? So now I might say, what's the air pressure at 500 feet? So 500 divided by 30, whatever that number comes, that's how many hectopascals less. Everybody okay with that? So 1013.2 minus 3 in the first question because it was only 90 feet. But 500, there's lots of 30s in there, right? So 50 divided by 30 will give you a certain number. Now, as a homework, figure out what is 500 divided by 30, 100 divided by 30, 1,000 divided by 30, 2,000 divided by 30, and memorize those numbers. Trust me, it will become so easy for you later on because you know the 500 divided by 30, you know it already. 100 divided by 30, you know it already. So if you have a question, what is the air pressure at 600 feet? 500 ka itna hai, 100 is this much, add that number. That's the number you have to subtract from 1013.2. Like I said, I was horrible in mathematics. Don't actually calculate. Find a well-calculated guess. You just have to be close enough. Everybody okay with what to expect in math tomorrow? I cannot sit and teach you multiplication, division, addition, subtraction mentally. I know it might be a very long time you've used a calculator, or maybe you have been using pen and paper methods. Maybe, I'm not sure if your background involved a lot of calculators or pen and paper methods. Majority of the students I see, when we meet them in Europe or in the Dubai branch or even in Australia, they haven't touched a pen and paper method in a very long time. So I asked them 100 minus 67 and they'll freeze. They have a glitch in their brain and they freeze. They're like, I need a calculator. You cannot do that, right? If you're in that level where you can't do simple addition, subtraction, multiplication and division mentally, you'll be in trouble. So please be very careful about these things, right? Everybody okay with that? Everybody knows what to expect? Cool? Let's just turn that off. I just wanted a 10-20 seconds.